Good morning and good afternoon. Hopefully everyone has had a great day today. Today I'm going to be starting a 6 to 7 part series of taking apart some STAAR questions from the 2018 all the way to the 2025 STAAR release tests. So what I would recommend for our students is to look at the problem that we're looking at, pause the video, try to work the problem on your own, and then after that check to see how you did the problem and whether you got the correct answer. Do understand that math can be done in multiple ways. So if you are getting the correct answer via your format, as long as you do the correct math, you should be getting the correct answer. So this review will be questions that are aligned to STAAR. They are from one of the 5 or 6 release tests that TA has put out. So once again, just pause the video, try the problem, and then see if you got the problem right. If you got the problem right, then you're on track. If you're not getting the problem right, then look at the explanation. Some problems I do solve 2 ways, so whichever way you think is easier for you, then you go that strategy. So once again, our students are going to be start testing on December 9th. So this is in order to get you ready to pass that STAAR test, and not just pass it, try to get you at the meet or master's level. So let's go ahead and get started. So if we look at question number 1, this is from our part 1 series. We're going to look at this question and we're going to say, well, which expression is equivalent? And you got to understand that equivalent does mean equal to negative 28 squared plus 35. So the first step is I'm going to get my Desmos Texas version or STAAR version calculator, and I'm going to go ahead and input this into Desmos. So I'm going to go ahead and input negative 28. So I'm going to use this calculator right here. I'm going to just input it the way it is, negative 28 square, x right here, and square, positive 35x. And that is your answer. We're looking at a quadratic, and if you see the quadratic, we do have a vertex. Looking at this, we do have a vertex of, right here, we have a vertex of 0.625 and 10.93. We understand that this is a maximum U-shape because, of course, the vertex is at the very top. So if the vertex was at the very bottom of the U-shape, then it would be a minimum, but this would be a maximum. So the first strategy is using our Desmos calculator and looking at every single one right here, F, G, H, and J, and all it would be is to input every single one and see which graph matches this. And remember, for it to be equivalent, it has to match the graph. So I would input 7x, open parentheses, 4x, positive 5, and of course, if you want to try the problem, pause the video and then try it out and then look at the explanation. All of a sudden, that one I know is not correct because that one isn't even close. The red and the blue are not even close to the graphs, and of course we can subtract it to see the graph, and we can add it to see the graph right there. So I know automatically this is not a correct answer, so then I would take it out, and I would recommend to leave the problem there. And if you leave the problem there, then of course you can go ahead and try it out and try. So if you do a mistake in inputting, you can go ahead and input the correct one. So this one is negative 7 x, open parentheses, 4x minus 5, close parentheses, and we're looking at the graph. So it looks like this is the winner for our problem. So looking at this, and of course I would check H and I would check J. Sometimes the graph does look very close, but if I would click the red one, the green one would stay. I would click the red one should be there, and I unclick the green one and it should stay. So automatically the answer choice is negative 7x. So my answer choice would be G. And the way I would check this problem is I would rewrite this problem, negative 7x, open parentheses, 4x minus 5. And if you can see this problem, it's a very easy distributive property. So I would distribute the negative 7x into the 4x. That gives me a negative 20x x squared, because x times x is x squared. And then I would distribute the negative 7x times negative 5, which gives me a positive 35x. And as I can see, this is the same as this. So what does that mean? They are equivalent. Sometimes the answer choice will not be G, so you keep on going until you find the correct answer choice. So I would recommend to do the problem using the calculator, number 1, and then number 2, checking it using the distributive property that we did learn in class. So that wraps up question number 1. Question number 2 is an easy one. And why is it an easy one? Because it doesn't require Desmos. And which graph best represents, and we're going to look at this one, which graph best represents a system of equations that has no solution? That is the key word of no solution. What does no solution mean? That they're never going to cross, they're never going to meet. Automatically, I can eliminate A because guess what? It crosses right here at this point. So this one is not a right answer. C I can eliminate because it crosses, and this one is not a right answer. So I'm down to B and D. As you can see, both of them do not cross, but if you look at this letter B, eventually, if you look at the lines, eventually they're going to cross off the paper. So I can eliminate B. Now, why is D the correct one? Well, D are parallel lines, and parallel lines never cross, and they never meet. So this one would never cross this one, so that means they'll never cross, and that means that that one has no solution. And the question at hand is which graph represents no solution? A is wrong. B, eventually it's going to meet off paper. C, it's wrong because it meets right there. And D are parallel lines, and they're never going to touch, and they're never going to meet. Okay, we go on to problem number 3. Given that f of x is equal to 1/3 4 minus x, they want to know the value of f of 16. So this is a simple function. The only thing that you have to know on this problem is knowing that f of x is 16 right here. And all we have to know, and let me erase it so you can see it. All we have to know is that x equals to 16. That is exactly all we have to know. So if we look at this equation, the f of x, you don't pay attention to that. All you're going to do is input the x, where it's 16, into Desmos and let Desmos do the work. So the way you would input it is I would do 1/3, and then I can open parentheses for minus my x value, and my x value is 16. And then I will go quantity square, and I have to close my parentheses, and that should give me my value. So if I put this into Desmos, I'm going to let Desmos do the work for us. I'm going to go ahead and put 1 divided by 3. Then I'm going to put a space here, or I'm going to push this arrow. I'm going to open parentheses, and then I'm going to go 4 minus x, which is 16. Close parentheses, and Desmos spits out the answer of -4. But what did I forget? I forgot my square. The way you do the square, it is a square. I put the a square, so my answer is 48. So my question of the evaluation of f to the 16 is 48. And remember, there's no need to put in f of x. You can put it in, but again, it's better to not confuse Desmos and just let it, just put in the bare minimum when you do your problems. If we look at number 4, this one's going to be an interesting one because we got to look at range. And here we got to understand that the range is your y. So remember, range equals to y values. So this is the key word to range. Now, automatically, A is wrong because of the x, so this one's wrong. B is wrong because that's an x. We're looking for range, so it can either be C or D due to the fact that it is a y. So once again, I'm going to go ahead and input this equation, this quadratic, which is a square, into Desmos, and you let Desmos do the work for you. So I'm going to go ahead and input the quadratic. It's going to be negative x squared. And one of the things I got confused on the other day was I forgot my x squared, could never get a solution. Well, I forgot my x squared. So usually the only way that you won't get a solution is because you did an inputting error. So that's why it's very good to go back and check your answer. And then we're going to look for the graph. Remember, they're looking for range. And I'm going to look for the graph, and there it is, and it's a maximum. Why? Because the vertex is at the maximum point of the graph. I look at the coordinates and I see x is -1. That's my axis of symmetry. X is -1, and y is 4. But again, the way I find whether what the range is, it's all my y values. So I'm going to be y. All my y values that are less than 4, but also equal to, because it's got that shape. And if you don't believe me, all you have to do is go up and down the graph. There's y value, goes from 3.8 all the way down. All those are ordered pairs, goes down, -0. So it's all my values, and I go on this side. The biggest one is 4. And go down, go down, go down, all the way to the negative. So my y value, the highest y value is -4. And of course, I'm going to click on it again. My highest y value is 4. So it's all the numbers that are under 4, but it also includes 4. So now we're going to look at the answer choices, and we're going to look at the graph. All the numbers less than 4. Y is less than or equal to 4, or y is greater than or equal to -4. Of course, if it would be greater than or equal to -4, it would start somewhere right here, and then it would go up all the way up. So this one is false. And once again, the vertex isn't even this. So the answer choice is C. Y is less than or equal to 4. We look at your vertex, we look at the y value. Is y less than or equal to 4? All the graph is less than or equal to 4, and that is the correct answer, letter C. The next one, if you look at number 5, which statement about the graph is true? Y equals to 8, open parentheses, 0.25. This is an exponential function. Why? Because it has this tiny little x right here, and that's called an exponential function. So it's an exponent. So what am I going to do? I'm going to go ahead and input this into Desmos. And the trick to this type of exponential function, the y-intercept, will always be this number. If it's in this format, the y-intercept will always be there, because we're going to let x equal to 0. But if you don't believe me, it's okay. We can input it into Desmos. Let me go ahead and clear this. I'm going to go ahead and input, and I don't have to put y, but if you want to put y, it's okay. You can put y. We're going to put 8, open parentheses, 0.25, close parentheses. And how do I get my little x to the top? All I do is go to the a to the b right here. I click on it, and it raises my power to the x. And sometimes I got to push it correctly, and there it is. There's my graph. And all I have to do is find out, I have my x-axis right here. If you look at this line, I have my x-axis, I have my y-axis, and I got my y-intercept. And remember, I got to click on it, and it's got to stay stuck. If it doesn't stay stuck, then it's not my y-intercept. So my y-intercept, where this graph crosses the y-axis, is 0,8. So now we're going to look at the answers. We're going to say, well, the coordinates of the y-intercept is 0,8, and there is my answer. So it is 0,8. Let me get the pencil in blue, and that is my answer, letter choice G. If I look at my x-intercept, if you look at this graph, there's no x-intercept. It's going to approach It's going to approach a number, but it's never going to touch the number. So it's going to approach the 0. The y is going to approach the 0, but it's never going to touch 0. It might pass it. It just depends on the equation. There it goes. It approaches, it approaches, it approaches. It's at 0, but again, it's never going to pass 0. At least in this one, I don't think it does. So once again, the x-intercept is 0.25. It would have been way over here, and that is incorrect. So I'm going to scratch it out. The equation of the asymptote is x equals to 0. That is false because our asymptote, if it approaches 0, it would be y equals to 0. So the asymptote x equals to 0, that's your imaginary line that passes through the y-axis, is false. And the graph includes 2, 1. So I go right here. I press on this, 2, 1. Nope, it's actually 2, 0.5. Does everyone see that? 2.05. This one is false. So the correct answer is G. The coordinates of the y-intercept are 0, 8. Let's go ahead and prove it. You click on this, 0, 8, and it sticks. So that is your y-intercept. So that is the answer to question number 5. If we go to question number 6, this is another quadratic, so I'm going to go ahead and delete it. The way we do this is we're going to go ahead and input this quadratic, which is a square. This is a quadratic because of the square right there. We're going to input this quadratic into Desmos as in column 1, and then we're going to input column 2, column 3, column 4, column 5, and remember equivalent means equal. So we got to make sure that it does equal. So let's input the first one, and it's a matter of just inputting it. I'm going to go ahead and get rid of this one. And then I'm going to input x squared. So I'm going to get my keypad out, and I'm going to put x squared minus 17x minus 60. And there's my quadratic. I have my quadratic. I'm going to have to zoom in, zoom out. On that quadratic, I have my x-intercepts as being -3 and 20, 0. So I already know my x-intercepts being -3 and 20, or my zeros are -3 and 20. I can go all the way to the bottom, and I can see my vertex. My vertex is 8.5, -132.25, and who does the work? Desmos does it. If I want my axis of symmetry, it's the x value of the vertex. My axis of symmetry is 8.5, but that's not the answer to the question. So the answer to the question is, and I don't want to zoom in too tiny because then I can't see which one the correct one is. So I need to zoom in and actually see it right there. And then I'm also going to check my work, my correct answer, using the FOIL method or the box method. Whichever one your teacher teaches you, that's the way you check the problem. So I'm going to input the first one, x minus 20. Close parentheses. I'm going to go ahead and open parentheses, x plus 5. And go ahead and try this on your own first and then check your work. And as I can see, the green one doesn't go on top of the blue one already. By looking at this, I don't see that it is on top. And if I want to zoom in, it still isn't on top. So you can zoom in, zoom out. Just try not to zoom in. Just try not to zoom out too much because then you can't tell the difference. So automatically A is wrong. So this one is wrong. And then B, let's check B. And I would recommend to leave it here because if you make a mistake, you can go back and check it. Where did I make my mistake? And this is an easy one that you can get correct on the STAAR test. I'm going to put x minus 5, close parentheses. I'm going to open parentheses. I'm going to go ahead and do x minus 12. Going to close the parentheses. Why isn't the graph anywhere? So I got to check it. Okay. There it is. It's not right on top of it. So automatically I know this one is wrong. Because sometimes it might say, okay, well, if I can't see it, and I'm right here, and I say, oh, it looks like it's on top. Well, all you have to do is unclick the blue, and it should be there, the purple, but it isn't there. I would click it, and I would unclick it, and I would unclick it, and I would click it, and of course, they have to be overlapping in order for them to be equivalent. So automatically, that is a wrong answer. you go to your grid and you get rid of B. But you can leave it there. Just uncolor it, then you input C. So let's go ahead and input C and find out if this is a lucky one. X minus 20, close parentheses, open parentheses, X minus 3, close parentheses. Once again, another one that's not right on top of it, so this one is not equivalent. So in this case, we had to try every single one. Most likely it's going to be the last one because in a multiple choice to start test, it has to be one. Right here, I'm going to input the last one, x plus 5. And again, you'll see that if we make a mistake, we can go back and then we can check the work. And maybe I made a mistake. And I'm going to look at this one and I'm going to say, well, it's not right on top. It's the red one. It's not right on top. And then I go to my original one. It should be right on top. So let me go ahead and check it. Let me see where I made the mistake. Well, here's a mistake. So even myself looking at this, doing it quickly, look at the mistake I made. I didn't input it as x plus 3. So that's probably why I didn't get an answer. So all I have to do is come back, and that's the reason why I leave it up here. This is a prime example of checking your work. I know it's not the correct one, and coming back, and all I have to do is click behind it and change it to a 3. And now I have x minus 20, x plus 3. And guess what? I'm going to click on it. It's right on top. You see the green? I can take out the blue. It should be the same exact thing. I can take out the green. It should be the same exact thing. So there is our lucky problem number 6. So once again, that is the answer. And so first I eliminated it and I saw, okay, there's no answer. So now the answer choice, and I'm going to, of course, bring my pencil, and I'm going to go ahead and answer this one as being my answer. Now, how do I check my work? I'm going to break down this one, and I'm going to go ahead and do the FOIL method. So I'm going to go ahead and write this down again, x minus 20. I'm going to expand it so you can see it. And then I'm going to do x plus 3. So I'm going to use my FOIL method, which is the first, outer, inner, and last. So in green, you're going to see it. I'm going to start off with the first term. And I do have a video specifically on FOIL method. So if you don't know how to do the FOIL method, I do instruct it. So I'm going to start off, it's just a double distributive. So I'm going to distribute x times x, and that is x squared. And then I'm going to distribute x times 3, and that is positive 3x. So what I like to do is I'm done with the first term. I get rid of that. Then I'm going to go ahead and go to another color of black. I'm going to underline my negative 12. And I'm going to distribute the negative 20 into x, and that's going to be negative 20x. And then I'm going to distribute the negative 20 into 3, and that's going to give me negative 60. Now, if I don't know what negative 20 times x is, all I have to do is say, well, what's negative 20 times 1, and that's negative 20, and how do I get that number? I just put it into Desmos and let Desmos do the work. If I don't know what negative 20 times 3 is, then all I do is put it into Desmos and let Desmos do the work. Next, I'm going to go ahead and combine like terms. The x squared is by himself. Then if you can see this, and I'm going to put it in orange, I have the positive 3x and a negative 20x. And I can put in 3 minus 20 into Desmos, and Desmos will do it for us. And it's like saying I have 3 cows and I take away 20 cows. Well, I'm going to have 17 cows, which is a 17 x's. And I get rid of that one. And then I'm going to bring down the minus 60 because it doesn't have a friend. And that is my answer using FOIL method. And I would have to have this one in order for it to be equivalent. So that is an extra double check for you to get it right. Unfortunately, I don't teach using the box method, but again, if you know how to do the box method, it's very similar to the FOIL, and you can also do that. But again, I don't want to teach it because number one, if you haven't learned it via the box method might confuse you. So I'm going to stick to that, and I'll do another video if you would like to do the box method, and I can teach via box method. So that is the answer to number 6. Prime example of why it's important to check your work, especially on these easy ones. Okay, we're going to look at number 7. So what is the value that makes n true? So this is going to be a simple one where they give us is n 3, is n negative 9, is n 0, and is n negative 15. So the way I do this, if you don't know how to do distributive property, you don't know how to solve equations, you don't know how to do any of that, all you do is draw your railroad sign right here, down the equal sign. So what you're going to do is you're going to test this side out, and if they both are equal, then that means that they're equivalent. So what does this mean? Well, this means 4 times 0, open parentheses, 0.5 times n, and you're going to test out the n as 3 first, minus 3, close parentheses. Whatever you get here has to equal to n, and the n is 3, and I would put it in here. N is 3, so then of course it's n minus 0.25, open parentheses, 12 minus 8 times n. And I'm going to show you a trick on how to do this on Desmos and to make it easier for you. So first of all, if you're taking an online version, I would just recommend to rewrite this on your white sheet of paper and then draw your railroad sign right there. And then after that you input the first one here into Desmos via the 3. And then you input this one here into Desmos via the 3. And then you get the answer, and if they're equal, they're equal. If they're not equal, then they're not equal. So let me go ahead and clear my work from the previous problem. So I'm going to go ahead and do this one right here. And I'm going to say, well, I'm going to say 4. I'm going to put 4, open parentheses, 0.5. And I'm just doing this side right here, 0.5. And I say, which one am I testing first? And I'm going to test n equals to 3. So I'm going to test it 0.5 times n. And what is n? I'm testing 3. So I'm going to do times 3 minus 3, because it's right here, minus 3. I'm going to close parentheses, and that gives me a negative 6, this side. And I'm going to do the same thing to this side, and I'm going to put it in column number 2. And remember that I'm testing 3, so the n is always 3. So I'm going to go 3 is my n, minus 0.25, and I'm going to go ahead and put that, 0.25. And then I'm going to open my parentheses, 12 minus 8, a little too many 8s, 8 times n, and I'm going to do times n, and what is the n we're testing? 3. And I'm going to close my parentheses, and I'm going to check it. Does negative 6 equal to 6? The answer is no. So automatically, I know this one is not a correct answer. So this one is wrong. So then I would check the second one with negative 9. So I don't have to re-input every single one of them. All I have to do is change the n to be, instead of 3, I'm going to put 9. In the second one, instead of doing the 3 and the 3, I'm going to just put not just 9, negative 9. And I'm just going to input that and see if it equals. And if it equals both sides, then it's a true statement. If it does not equal, then it's not a true statement. So all I do, instead of the 3, I click behind it, and all I do is input negative 9. And then I come to the bottom and change the 3 to a negative 9. And then I'm going to change this number because of the n over here. I'm just going to change 8 times 3. I'm just going to put negative 9. I let Desmos do the work, and guess what? Desmos got it right, so that is your answer. So the answer choice is G. So once again, that is your answer choice. I would recommend to do this one and to do this one, and also to solve it via distributive property and solving for the n. So once again, that is the answer. Test it out. Do it on by yourselves on Desmos and find out that it doesn't equal. So let me give you the problem one more time. Look at the problem, test it out, pause the video, rewind it, and try it again. But once again, the answer choice is G. And remember that anywhere where there's an N, you're going to replace these numbers and you're going to make sure that this side is equal to that side via the Desmos format. So that concludes number 7. We're going to move right along to number 8. So if you look at number 8, now we're dealing with a quadratic. Why is it a quadratic? Because number 1, it's a U shape and it's going to have a maximum. So key features on this quadratic, and let me go ahead and clear my stray mark. Key features, we have a 0 right here at 0. We have another 0 at 4. Those are going to be your key features. Then we have a vertex. If you see it right above this green line, my x value is 2, and my y value, which is the feet above the ground, is 64. So what I'm going to be looking for is I'm going to be looking for these key features. The zeros, which are your x-intercepts, which is t, and then h of t is the same as writing y, and the t is just another format of just writing x. So this is the x. Remember that this is always the x here, and then this is always the y. So all you're going to do is input every single one in Desmos, and whichever one has a 0 as 0 and 4 and has a vertex of 2, 64 is your correct answer. And once again, this is a maximum and this is a quadratic. So we're going to input the first one, and remember, we don't have to put h of t. If you want to, you can, but it's going to confuse Desmos if you don't input it correctly. So I would recommend, don't worry about the h of t. There's no need to worry about that h of t. All you do is input the quadratic and let Desmos do the work for you. So I'm going to input the first one, and instead of putting t, I'm just going to put x. Instead of putting t, I'm going to put x. So I'm going to do negative 16x. Remember, even if it's an m, you can put x. There's no need to worry. Just put an x. Minus 64. So I'm going to find my graph. And what did I do wrong? Of course, I didn't put the t. I got to put that x. No wonder it's going crazy. And that is the purpose of making sure that I leave the graph alone. First of all, I'm looking for a graph that has an x0 as 0 and 4. So this one has a 0 of negative 4, 0, and has a 0 of 0, 0. This does not have a 0 of negative 4. It actually has a 0 of 4. So this one automatically, and let me get this so you won't confuse yourself with them being wrong. So this one would be wrong because it has a 0 and negative 4. It doesn't have a 0 at 4. Then I'm going to leave it there because there could be an issue that I don't input it correctly. And all I have to do is unclick this and input my second one. So I'm going to go ahead and input my second one, negative 16x squared. And try this by yourselves. You don't have to wait for me. You can do the work. You can input it into Desmos. Let Desmos do the work for you. All you have to do is find the correct answer via the Desmos format. Okay, so I have this. Let me double check that I inputted it correctly. There it is. There it is. So I'm going to subtract. Look at that. So this one has a maximum, that is correct, but look at where it has our maximum. It has 4, 0. It only has 1 0. This one has 2 zeros, so automatically this one would also be wrong. So I'm going to check my third one. So once again, I eliminated 1, I eliminated 2 just by learning how to do Desmos. You let Desmos do the work, and then of course you're going to go ahead and get the problem right. A complicated problem that becomes super, super easy. So let me make sure I input it right. Negative 16x squared, and then I'm going to add positive 64x. let's check my 0. My 0 is 0, 0, and the 0 is 4, 0. So far, I got my zeros correct. Now I'm going to look at my vertex right here. My vertex is 2, 64. And there it is, 2, 64. So most likely, this is the correct answer. So the answer is C. But you can go ahead and check if D is correct by inputting it. And I can tell you, just by knowing this problem, that is not the correct one. The correct answer is D. But I do want to check it. I want to make sure. This is an easy problem, and I want to make sure that it's correct. So I'm going to unclick this, and I'm going to go ahead and input my last one, just to make sure that I get this correct problem. This easy problem correct as x squared, and that I don't just, oh, I got the right answer, but then I didn't get the right answer, but then I didn't get it correct, but then I got the wrong answer. We always want to get the right answer, especially on these easy problems that all you do is match them. So let's look at D. Let's look at look at it. The vertex, the 0, is a maximum. It is a maximum, but look, it doesn't have zeros as 0, 0, and 0, 4. Automatically, that one is wrong. I proved it wrong. My vertex is negative 4, 0. The vertex is not 2, 64. So automatically, I knew my hunch was correct. I double checked it. And of course, C is correct. So that is how you do that one. So we're going to do a similar one. Which statement is true about g of x, as x squared minus 576 is true? And it gives you answer choices. So I would pause the video, try to do that one, check it to make sure you got it correct. So let me go ahead and clear the calculator, and then I'll go ahead and start working it. Number 9. So what I'm going to do, and you don't want to input g of x, it's better just to ignore it. You're just going to input into Desmos x squared minus 576. So I'm going to go ahead and input x squared minus 576. And now I'm going to find my graph. Let's see what the graph, there's my graph. I have my zeros. 1 0 is negative 24. And my other 0 is 24. So just by looking at the graph, I got to check to see if I inputted it correctly, and I did. So now, looking at that, the first one says the zeros are negative 288 and 2. That is false, because once again, my 0 is negative 24 and positive 24. That's wrong. G, the only 0 is 288. That's also false. Why? Because the 0 is negative 24 and 24. That is false. H, the 0 is negative 24 and 24. Well, that is correct. So I'm going to check to make sure that is the correct one. And the only 0 is 24. That is false because I have 2 zeros on this graph. So this tells me it's false. So the correct answer is H. And of course, if you want to solve it using the difference of squares method, you can, by setting it equal to 0, and you factor it, and it's x plus 24, x minus 24, which also gives you h. That is your answer. Or you can even solve it by looking at this and saying, well, what's the opposite of 24? Negative 24. What's the opposite of negative 24? Positive 24. You can set them equal to 0, and that is your answer. So once again, lots of ways to solve this, and probably there's additional ways, but again, it's all a matter of learning the Desmos, and Desmos will do it for you. Okay, so if you want to work number 10, what is the solutions of x plus 7 quantity squared equals 81? So what are we going to do here? We're going to check every single one of these, and we're going to input it into this, and the one that is the correct answer, that equals to 81, is going to be the correct answer. So all I have to do is input this. You may want to put the x, but you're not checking it that way. You're not going to put the x. If you want to put the x, you can, but it's not going to give you anything. You're going to put 6 plus 7 quantity square, which is the a square, and it gives you a U shape. Does it give you something? Well, it gives me negative 7. It kind of gives me something as negative 7. It gives me a y-intercept. Let me make sure I got it correct. X plus 7, quantity squared, that's correct. So it really doesn't give me much, and I'm so confused. I don't know what I'm doing. So I look at that negative 7. Maybe it's 74. I don't know. Who knows? So what the ultimate goal of this is to test every single one, and whichever one gives me 81 is the correct answer. So let me go ahead and input it. So I would put open parentheses. What is my x value here? I'm going to test out negative 74. And in order for me not to have to put in everything, I'm just going to exchange that negative 74 with the next one to see if it's correct. And then, of course, the x is negative 74. I'm going to add 7 to that. And then I'm going to close it. I'm going to go quantity square. And that gives me 4,489. That does not equal to 81, so automatically F is out. So I don't need to check it unless I see that I don't get an answer, then I made a mistake on my math. The next one I would check would be this one. So I'm going to do it in red. Let me get or in green. Let's do it in green. I would check negative 2. So instead of putting negative 74, I would put negative 2. So negative 2 plus 7 right here, negative 2 plus 7, quantity squared is 25. That does not give me 81, so automatically this is wrong. So I'm going to check the next one. I'm going to go to negative right here, negative 88. Instead of negative 2, I'm going to put negative 88. And that gives me 6,561, not even close to 81. So most likely it's the last one. So I'm going to go ahead and input so I can check it, so I can prove my answer is correct. And then I'm going to get rid of the 18, that big number, negative 88, and I'm going to put negative 16. Well, there it is. It gives me 81, but I want to be the correct one. So I'm also going to check the second one to go ahead and check to make sure that I got the right answer. So I'm going to, in place of 16, I'm just going to put 2. And it also gives me 81. So I double checked it, and my answer is letter J. So that is one way to get the answer. The second way to get the answer, and I'm going to show you the solution and the steps, and I don't expect you to do this because we've never covered this in class. But again, if you know how to do this, you can go ahead and do this. So I'm going to go ahead and rewrite my problem. X plus 7, quantity squared equals 81. So remember, what I do to one side of the railroad, I have to do to the other side of the railroad. So in order to get rid of a square, I would take the square root of this side, and I would take the square root of this side. So the square root of x plus 7 quantity squared is just x plus 7. And the square root of 81 is equal to plus minus 9. Because, of course, square root of 81 is 9. And square root of 81 is also negative 9 times negative 9 is 81. So I would just split this into 2. So this would also be x plus 7 equals 9. And then I have x plus 7 equals negative 9. So I would solve both sides. I would subtract 7 here. Subtract 7. That gives me x equals to 9 minus 7, which gives me 2. There's one answer. And then I would do the same thing on this side. I would solve the equation, and I would get rid of the positive 7, so I would subtract 7 also, and I got to subtract 7. X equals to negative 9 plus negative 7, which gives me a negative 16. And negative 16 is also your second answer. So you can solve and check via that format. And then that way you understand that we're also doing square root. So this would be the manual way of doing things. And if you know how to do this method easier first, then you do this method and then use the second method to check. It's really your choice the way you want to do this. Okay, so let's go on to problem number 11. So let me go ahead and clear my page. And we're going to look at what we have for problem number 11. So I have number 10 done. And then I just have a repeat of this one. Problem number 11. It just scanned it twice. So if you look at problem number 11, I have the water level. It's a linear equation. Why? Because it is a line. So it keeps on going up and up and up and up and up. So this, I can get my rate but they're asking specifically about the y-intercept. So if you look at this, they're not asking for rate. Even though I can find my rate, I can find that. But remember that this is my x and this is my y. So I'm going to put my x comma y, and I'm going to open parentheses, and I'm going to look at my y-intercept, and I'm going to circle my y-intercept right here. So they're asking which statement best describes a y-intercept. So this gives you a 0 is the x, and my y is 16. So let's read each one and let's find out if it's correct. Which statement best describes a y-intercept, which is this one, 0, 16. So at 0 number of days, my water level is at 16. And the water level of the river increases, so it means it's a positive rate of change. And do remember, the rate of change is a slope. Slope is rate of change, but they're asking specifically about y-intercept, which is what I circled in blue. So again, it's a positive slope. I'm going to look at the first one. The water level increased by 0.25 per day. Might be correct, but they're asking about the y-intercept. The maximum water level is 19.5. Well, that has nothing to do with this. We're asking about the y-intercept, so automatically that is wrong. F might be wrong, but I want to go further. The initial water pressure or the water level is 16. Well, my water level at 0 days and my water level is at 16. This looks kind of right. And my water level was measured at 14 days. Well, it is measured, but that's not my y-intercept, so this one is wrong. Now I'm stuck between F and H. Now if they would ask which statement best describes my rate of change, then I would input 2 points on Desmos, let Desmos do the work, and let it spit out y equals to mx plus b, and get that. But they're asking about what is your y-intercept. My y-intercept right here is the initial water starts at 16 feet. So that is the answer choice, letter H. And once again, my rate of change is positive. Most likely it is this one, but again, they're not asking for rate of change. They are asking for y-intercept. Okay, we're going to go on to our next one. This one's an interesting one because which situation best describes something that is not causation? So remember that we did in class, what is causation? Well, it's cause and effect. You do something, it's a cause and effect. Something happens. It's not an opinion, it's more cause and effect. So let me go ahead and delete this page, so then that way it can be cleaner. Okay, so which one of the following is a causation? Not a causation. So it's not a cause and effect. So let's look at letter A. And you can try this out. You can pause the video if you want, and you want to answer which situation is not a causation. Let's see if it's correct. You can try it out, pause it, and then try it out. And then we'll go through it together. When the student population at a school increases, the number of teachers at the school increases. Well, when you get more students, you're going to have more teachers. That is a cause and effect. It's also what we discussed, also association, because it's both causation and association, but they're just asking about causation. So this would be a causation and association. So this one is not causation. This one is causation. It's cause and effect, but the question is which situation does not show causation. So technically you got to read it correctly. When the amount of sugar of a quart of apple juice is reduced, there are fewer calories in each serving. Of course there's going to be fewer calories, and that's the same for Arizona, California, McAllen, Harlingen. The first one is the same. In California, McAllen, Harlingen, South Padre Island, a school population increases, you're going to have the same number of students. So this is a causation. This is also an association because they're associated with each other. But it does not show, which situation does not show causation. That's false. Let's go to C. When there are more workers on a project, the project is completed in less time. Of course, if you have 100 workers, it's going to be completed in less time. This is a cause and effect. If you have more workers, If you have more workers, then of course, the more you have, the less time the project is going to be completed. So that is false. It's a cause. It's a cause and effect. And D, when there is more protein in an athlete's diet, the athlete scores more points in a game. This is an opinion. Why? Because 100 players can have the same diet, and some can score less, some can score more. In McAllen, they can score less. In Harlingen, they can score more. So which situation does not show causation? When there is more protein in an athlete's diet, the athlete scores more points in a game. The answer is letter D. If we go to number 13, the keyword here, you look at the problem and try to find what the keyword is. The keyword here is which is the best estimate of rate of change. And once again, rate of change is the same thing as writing slope. And once again, rate of change is y equals to mx plus b. And remember, the m is the slope. The m is the rate of change. So I'm going to find some easy ones to deal with. And I like to deal with 0, 0, but let's say you don't want to deal with 0, 0. I can also deal with right here. If you look at this point, it's actually 1, comma, 400. Because 1 is my x, 400 is my y. I like to deal with 4 also. Let's see what this one is. This point right here. It's 4, comma, and then you look at where it goes. And I'm going to shrink it. It's going to be 4, comma, 1,600. And don't get scared with those big numbers. I have 2 points. I can even deal with the 2 because it has a good one. 2, comma, 800. I can even deal with the 3. 3, comma, 1,200. So I can use any of those points. But again, in order to input into Desmos, all I need is 2 points. I'm going to use these. You can use your own. And remember, they're asking for the rate of change. What is the rate of change? Slope. And it's the number next to the x in the y equals mx plus b. So I'm just going to use my table format. And I'm going to input those 2 ordered pairs. So I'm going to input 1, comma, 400. 1 being your x, the 400 being the y. Then I'm going to input 4, comma, 1,600. And then I'm going to add regression here. And I have my answer right here. So y equals to 400x plus 0. So already I know my m. Right here, if I rewrite it, it's going to be y equals to 400x plus 0. And my 400 is my y. It's right here. 400 is my slope. And the only one that is my slope is letter C. Just by letting Desmos do the work for you. So once again, if you know how to do the calculator, try it out. Do it by yourself. Get those coordinates. And if you know how to do it, go ahead and do it. Next one. Which function is equivalent to f of x equals to negative 4, open parentheses, x plus 7 quantity square minus 6? And you can even do 15, which is a factor of that. Well, it's got to pass through the x-intercept, and the first one has to be a matching one. So the first one I'm going to do is number 14. If you want to try those 2 problems together, you can. But remember, you don't want to put the f of x. All you want to do is put this into Desmos and let Desmos do the work for you. Then you start inputting every single one. And remember, in order for it to be equivalent, it's got to be equal. So I'm going to go ahead and input the first one. And I'm going to go negative 4, open parentheses, x plus 7, quantity square, minus 6, close parentheses, and there is my shape, and there's my vertex. I have some y-intercepts going on. If I want to enlarge it, I know where my shape is. That is actually a maximum. So I'm going to go ahead and input every single one of them and just see which one matches exactly. So I'm going to start with the f, and you don't want to put f of x, you just want to put in the quadratic. So on the second one, I'm going to just put negative 4x squared minus 56x minus 202. And it's somewhere there. Let's see if it's anywhere there. Oh, it looks like we have a winner. But let's check to make sure it's right. So you got to unclick this one. It's got to be there. You unclick it. You click it. Unclick it. It's got to be 100% identical to the question. So it's got to be 100% identical. If it's 100% identical, then that is the correct answer. If it is not 100% identical, then you have to go in and check every single one of them. So I would recommend try checking them out. I know for the sake of time we got lucky on our first one, but you also have to check my work because of course I could have just said, this is the right one, and it isn't the right one. So you have to go in and check the work. And if this one is not right, you got to disprove me. You got to disprove me wrong. So you would input every single one of them. And most likely it is the correct one. Most likely. Never 100%. I always say 99% because of course if I'm wrong, then I'm still right. So let's go to number 15. Which expression is a factor of this? So what we're going to do is we're going to input this into Desmos right here. And remember, factor means x-intercept. It has to cross the x-intercept. So this is my U shape. I'm just going to give you an example. This is in green. You're going to find my U shape. You're going to see my line right here. This is my x and this is my y. And this is my U shape. So I'm going to look at my x-intercepts. This is one x-intercept and this is another x-intercept. So you're going to find a linear equation that passes straight through that line. It's got to pass straight through the x-intercept. If it passes straight through the x-intercept, then it's a factor. If it doesn't pass straight through the x-intercept, then it's not a factor. So the first step, let's put this one in. And we're going to input as 21x squared positive 13x minus 20. And there it is. So I see it and it looks tiny. So you want to always enlarge it so you can look at your x-intercepts very clearly. And I want to make sure I did the correct one, 21x squared plus 13x minus 20. There's my x-intercept and there's my x-intercept. So then what I'm going to do to find that it's a factor, and remember it has to stick. Those my x-intercept, that's my x-intercept. So in order for it to be a factor, it's got to cross straight. The line has to cross straight through my x-intercept. So I'm going to go ahead and try my first one and find out if it passes through my x-intercept. And I want to have those x-intercepts big so I can see them and see that it passes straight through those black dots right there. So I'm going to input the first one as 3x minus 4. And it doesn't pass through my x-intercept. It has to pass straight through the middle. So automatically, looking at this one is wrong. I'm going to go ahead and unhighlight because some of you like to put all those lines and you're confused. But you unhighlight it and you check the second one. I'm going to go ahead and input 7x minus 5. And there it is. It passes straight through the x-intercept. So my answer choice is letter B. You can go ahead and try C. You can try D. But the correct answer should be B. So that is the x-intercept. If you look at 16, let's take a look at 16. 16 is they're asking for, this is an exponential function. There's practically nothing you can really do on Desmos to get the answer right, other than knowing the definition. So the definition, which one appears to be the domain? And we're looking at the keyword as being domain, and that is your x. So let's look at the answer choices and let's wipe them out. So if it's an x, we can automatically get rid of this one. B is wrong, and we can get rid of D. So now we have to check, is it this one or is it this one? Is x between -1 and 3, or is x between 5.3 and 27? So we're going to look at the graph, and they're both shaded, so it's going to be shaded equal to. So all I do, and since my domain is my x value, I'm going to write down domain here. And in blue, I'm going to circle this one right here, and I'm going to trace all the way down, and I'm going to circle my 3. So my domain is, my x value is 3, and then I'm going to circle this right here, and I'm going to circle -1. So my domain is anywhere from -1 to 3. Now let's look at your choices. My domain cannot be less than -1, and it can't be -2 or -3, -4, -5, because it's not part of the graph, the domain. My domain cannot be 4, 5, 6, because it doesn't have an arrow and it's not going to continue going. So if I look at the choices, the only choices that we have is letter A. So the domain is between -1. -1 is less than or equal to x, and x is less than or equal to 3. That is my answer choice. Of course, this one is wrong due to the fact that they're actually telling you about range. We're not looking for range. Remember, the key word is x for domain. If we look at the next one on number 17, and we're looking at that one, and we're saying, well, what is the rate of change? And remember, the rate of change is, the key word for rate of change is slope. And remember, rate of change is slope. Slope is rate of change. So what I'm going to do is I'm going to go ahead and input this into the table format. So I'm going to go ahead and put these values. Week is x, and range is, of course, your y. X is the weeks, and y is your balance. Because remember, as the weeks goes on, there's dependence and independence. And of course, the x's are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And my balance is 32, 39, 53, 74, 88, and 123. So all I'm going to do is input those values. 0 goes with 32. We're going to go to 1 goes to 39. As the weeks increases, the dollars increase. So we know it's going to be a strong negative just by looking at it. 3 goes to 53, and they are in order. So it's got a correlation factor of a strong negative. We're looking at 353. Then I'm going to do 674. You can technically, with about 3 or 4, since it is linear, it's going to continue going. But for the sake of what I want to do is I just want to input all of them. I like to input all of them. But if you just want to input 3 of them, you can input 3 of them. Should give you the same answer. But you'll kind of calculate your correlation and everything with it. So it's better to put in all of them, because you always want to be perfect on these problems that are a piece of cake. And then of course I put them in, I check them, and then I'm gonna click on the regression, and there we go. It's a linear, and just by looking at the equation, it tells you right there my correlation factors are equals to 1. So that is a strong positive. So the correlation is 1, is very, very strong. If you're looking at this, y equals 2, and I'm going to look at that. Y equals to 7x plus 32. If a question was, what is my slope or my rate of change? My slope and rate of change is 7, because this is your m. And if they're asking for me my y-intercept is this one, which is positive 32. But they're not asking for that. They're just asking for what is the rate of change. My rate of change is the same thing as slope, and my slope is 7. So once again, slope is 7. And who does all the work? Desmos does all the work for you. So we're going to look at number 18. Which expression is a factor of 9r squared minus 4r plus 1? So once again, you can go ahead and input this one into Desmos and find out. Remember, a factor states it has to cross directly at the x-intercept. So what I would do is I would graph this. But again, you cannot graph that one. There's no r's, there's no y's. The best course of action is just to rewrite it as an x squared. So that would be 9x squared minus 4x plus 1. So anything, whether it be an M, an A, or a B, you can always rewrite them to x's. And that makes Desmos do the work, and it makes it a lot easier for us to do the work. So I'm going to go ahead and submit it. I'm going to go ahead and put 9x squared minus 4x positive 1. And remember, on the STAAR test, every single problem will reset. This tells us something very unique, because remember, a factor has to pass through the x-axis. Look at that. It's a minimum, it's a vertex, but it doesn't pass through the x-axis. So how can we find a line that passes through the x-axis? Well, we can't. So guess what? This one is letter J, because it has no real factors. So once again, you can input this in quadratic formula. It's going to give you probably imaginary, because it doesn't have anything there. You can input those, but again, it's got to pass through your x-intercept. And this one, just by looking at that, it has no x-intercepts, so there are no real factors. If I inputted it correctly, that is correct. It's got to pass through the x-intercept, so that is number 18. Try them out. Check to see if you know how to do them. Look at this one. Number 19 is a good one. Look at what it says. Which graph best represents a quadratic function that only has one zero? And remember the key word for 1, 0. A 0 is where it passes the x-intercept. A 0 is the same thing as x-intercept. A duck is the same thing as a duck. 0 is the same thing as an x-intercept. So once again, it's just the same exact thing. So we're going to look at each graph, and they want to know one quadratic function that has only 1 0. If you look at A, has a 0, has a 0. It's got 2 zeros, so this one is wrong. Let's look at C. Does this one only have 1 0? Lies. Here's 1 0. Here's another 0. So that means C is wrong. If I look at B, does that one have 1 0? So in red, there's that 0. It only crosses my x-axis at 1 0, or 1 x-intercept. So there's my answer choice. If I look at D, does this one only have 1 0? Nope, doesn't even cross my x-axis. I want it to cross my x-axis. It doesn't even reach my x-axis. Look at my red. Doesn't even reach it. So this one actually has no zeros, or no x-intercepts. Let's look at number 20. What is the slope of the line that passes through points 5, negative 11 and x, negative 9 and 17? Very simple. All you have to know is that x, y is my ordered pair. So all I do is input this into table and get my y equals mx plus b. So I'm going to go ahead and input it into the table. And I'm going to put y equals 2, x equals 2, and y equals 2 right here. This one is x and this one is y. So I'm going to put 5, negative 11. Whoops. 5, negative 11. And I'm going to put negative 9, comma 17. I'm going to add regression. And there's my answer. Y equals to negative 2x minus 1. So in blue, I'm going to underline my slope. My slope is negative 2. My rate of change is negative 2. So my slope is letter A. Now, how can you check this? Well, very simple. Something we covered in algebra class was that you have 2 points. And if you wanted to check whether Desmos did it correctly or not, all you have to do is label them. And of course, this is more complicated. x1, y1, x2, y2. And you use the slope formula. And the slope formula gives you your slope. And it would be y2 minus y1 all over x2 minus x1. This is your slope formula. So what I would do is I would say y2, 17, minus negative 11 divided by x2, negative 9, minus x1, 5. So what I would do is I would input this into Desmos to get my answer. But if I learned my first week of school, I would go, this is a keep change, plus, plus. So that gives me a positive 28 divided by plus minus, that gives me a negative 14. And if I put this into Desmos, should give me a slope of 28 divided by negative 14, which gives me a slope of negative 2, which is the same as Desmos. So that is one way to check our answers. So that concludes our number 1 through 20. So this is part 1 of our review. I will be uploading, this is all I'm going to upload until I get back from vacation. So I'm going to upload 21 through 40 on my next video. Then I'm going to upload 41 through 60, 61 through 80, then 81 through 100. So then that way I can chunk them in groups of 20. Thank you so much for your time. Have a great, great vacation. And once again, I hope my video has shown you how to do the problems and how to do the step-by-step structures. Please don't hesitate to reach out to me anytime. I'm here to support our students, and I want to make sure that you understand the Desmos calculator. I would recommend to go back, redo the problems, and pause it, try the problem, and see the working out, see if it is correct the way you worked it out. Have an amazing, amazing day or afternoon or night. Thank you for your time.